Hello everyone, welcome to Dheeraj Academy. I am Manisha, your maths buddy. Today we will do about the study about the fundamental theorem of arithmetic. So what is this fundamental theorem of arithmetic? It's nothing, it's simple that every number, what do you think that every number can be broken into the smaller building blocks? That means into the simpler numbers. Yeah. So you can take any integer. Suppose you are taking 6. So can it be broken into the smaller numbers? Yes. 2 into 3. Yeah. So is there one way to express a number into the product of times? There can be the different way, but the final thing will be the same. Yeah. And you know that what are the prime numbers and composite numbers? So prime numbers are the integers with exactly two distinct factors, that is the 1 and itself, like the 2. So 2 has the factor 1 and 2. If I am taking the 7, it has the factor 1 and 7 only. So these are the prime numbers. But if I take the 8, so it is that 2 times 2 times 2, or you can write as 2 times 4. So that means these integers have more than 2 factors. They have the 1. So 8 has the factors 1, 2, 4, 8. So it has the more than 2 factors. So these are the composite numbers. Yeah. So now the fundamental theorem of arithmetic. Yeah. So it's proof overview. So the fundamental theorem of arithmetic demonstrates that every integer which is greater than 1 can be expressed as a product of primes through the consecutive factor tree reasoning. And it is widely used in finding the highest common factor and the least common multiple. What does this theorem states? Yeah, the fundamental theorem of arithmetic states that every integer greater than 1 is either a prime number itself or can be represented as a unique product of prime numbers. Yeah. So what is the unique product? Unique product means their numbers are unique to the one number. If the number changes, their prime numbers factors will also change. Yeah. So the numbers which has the factors other than the one and itself, we call them as the composite numbers. Yeah. And their factors are the unique to the numbers. Suppose I am taking the 16. Yeah. So its factors are the 1, 2, 4, 8, 16. So these are unique to this number, or we can write it as the product of prime numbers like in this way. Yeah. So their sequence can be changed, but the numbers, the factors will be the same. Suppose I am taking the example 12. Yeah. So it's your, I can write it as the 2 times 2 times 3 also, or I can write it as the 2 times 3 times 2 also. Yeah. Or I can write it as the 3 times 2 times 2 also. But the actual prime numbers will be the same in all the cases. So this is the uniqueness, and they are unique to the number. You can see for the 12, these are the this numbers, and for 16, there are 4 twos. Now we can prove this theorem, fundamental theorem of arithmetic, that every number can be broken into the primes. So let's take the 48. Yeah. So we will do the step-by-step breakdown. So this is your the factor tree. So by the factor tree, we can simplify the 2 times 24. Then we can split again 24 into 2 into 12. Then we can split till we will not get the prime numbers. We will go on splitting the number. Yeah. As 6 is also not the prime number, so we will split it again. Now we have reached to the prime number, so we will stop our factor tree. So in this way, we can break down our numbers. Yeah. So 48 equals to the 2 times 2 times 2 times 2 times 3. That means 2 is repeated 4 times. So we can write it as the 2 to the power 4 times 3. Now can a number have different prime factorization? Can we do it in the different prime numbers? So let's check with the 36. Yeah. So there are two different paths. One is the we can do the directly the prime numbers. So this will give you the 2 times 2 times 3 times 3. Yeah. Now the second path is 6 times 6. Yeah. But 6 is not a prime number. So we have to factorize these 6 again. Yeah. So it will become 2 times 3 and 2 times 3. But the final result is same whatever way we choose. Yeah. So whatever path we choose, but the ultimate, the target or ultimate result will be the same. So that is the uniqueness of this fundamental theorem. Now, where we can use this fundamental theorem? We can use it in finding the HCF by using the prime factorization method. Yep. So let's take the finding the HCF of 18 and 24. So what should be our first step? The first step should be the factorization. So we will start the factorization of 18. So we will do it 2 times 9. But 9 as it is not a prime number. So we have to make it tree again factor tree. Now this is 3 times 3. So these are the prime numbers. Yeah. So we can write the 18 as the 2 times 3 times 3. That means it is your the 2 times 3 square. Now we will factorize the 24. Yeah. So it's your the 2 times 12. 12 is not a prime number. So we will do it again. So 2 times 6. 6 is again not a prime number. So 2 times 3. So the factor tree factors of 24 are 2 times 2 times 2 times 3. 2 is repeated 3 times. So we can write it as the, how can we write it? 2 to the power 3 times 3. Yeah. Now we have to take the common primes. Yeah. Or best you take the minimum powers when we have to find the HCF. Yeah. So there are two types of prime numbers, 2 and 3 in both the numbers. Yeah. So in 18, there is 1, 2. So that means the power of 2 is 1. In 24, the power of 2 is 3. Yeah. So we have to take the minimum power or lowest power. So we will take the 2 to the power 1 here. In the 3, in the 18, we have the power 2, you can see here. And in the 24, we have no power. It means we have the power 1. So it has the 1. So we have to take the minimum power. So it will be also 3 to the power 1. So HCF will be your 2 times 3, that is equal to the 6. Yeah. So in this way, we can use this in finding the HCF. So what you have to do? First step, do the factorization. Second step, take the common primes and choose their minimum powers and multiply them, and you will get the product which will be your required HCF. Now let's see how to find the LCM. Yeah, we are using the same number, that is the 18 and 24. So we know that the factors of these two numbers. Hmm? What we have to take here? In finding the HCF, we take the minimum powers, but in finding the LCM, we take the maximum powers. So that is the main basic difference in finding the HCF and LCM. Yeah. So here we have to choose the maximum powers. So its maximum power is 3 for the 2 to the power 3, and for the 3 maximum power is 2. So we will choose 3 to the power 2. So what would be our LCM? LCM will be 2 to the power 3 times 3 to the power 2. Yeah. So that will be your 2 to the power 3 is how much? 2 to the power 3 is your the 8 times 3 square is your 9. So 8 times 9 is equal to 72. Hmm? So in HCF and in finding the LCM, your the first step is common to both of them. You have to do the factorization by using the fundamental theorem. And then when we find the HCF, you have to take the minimum powers. Yeah. And when you are finding the LCM, you have to take the maximum powers. Yeah. So what we have studied in this our today's session, that the fundamental theorem states that every number which is greater than 1 can be written as the product of primes. Hmm? Factorization is unique to the number, only their order can change. Hmm? And the prime numbers are the building blocks of all the numbers. Through these prime numbers, we can make any infinite numbers. Yeah. So we use this fundamental theorem in finding the HCF. Yeah. By taking the minimum powers, and LCM by taking the maximum powers. I hope that this video will help you in better understanding of the topic fundamental theorem, and will give you the easy understanding. If you like this video, please subscribe it so that, and you can take the demo also, you can book your demo also. So please subscribe the Dheeraj Academy and this video. And if you want the demo, then also you can book your demo session from the below link. Thank you. So please watch this video and try to subscribe it so that you can take the demo also if you need.